This is Unit 5, right triangles. Preview video 5.2, special right triangles. Sit tall. We're going to inhale through the nose. Ready? 3 count. Inhale. Hold. Exhale, 5. Close your eyes. Do it again. Hold for 3. Exhale, 5. All right, students, let's do this. We're going to be learning about something called special right triangles, but let me just give you a heads up. Right triangles in general are the most important shape you will study in geometry. So right triangles are what I will call the key to the universe in geometry. Right triangles unlock hundreds, thousands of practical applications. There are 5 tools you're going to need to memorize over the next 2 weeks. These tools are in your reference booklet, and there is a cardstock page in the middle of your reference booklet that looks like what this page looks like. There's 3 tools on one side, 2 tools on the other. This must be memorized. The 5 tools of a right triangle are Pythagorean theorem, 45, 45, 90 triangles, 30, 60, 90 triangles, something called SOHCAHTOA, then inverse SOHCAHTOA. I will collectively call this sheet your best friend because it will be the most important thing to you through this unit and multiple units in the future. Right triangles are related to hundreds of different professional applications, including the medical field. The insertion here of a syringe has to be at a certain angle, right triangle, calculated, hits the vein at a certain amount, etc., to deliver medication. Aviation, navigation, believe it or not, solving crime, triangulation of blood spatter patterns involves right triangles. Of course, architecture, anything that's physically built, forestry, the analysis of ecosystems, conservation, and communication. All of these involve right triangle mathematics. Quickly, put a star by the one that you find most intriguing. Put a star by the one you find most intriguing. Last class, you learned this in a right triangle, that you have a right angle there, and connected to the right angle is a leg. Connected to the other right angle is another leg. And then the hypotenuse is across, or the right angle points to the hypo. You guys probably have encountered this equation in the past in this form as a squared. So there's the a side, and then you can see we square it, a squared. There's b side, and you square it, b squared, that's 3. And that is, when you square it, gives us 9. And here, when you square this 4, 16 equals what's called the hypotenuse squared, c squared, and it's 25 squares. So 9 plus 60 equals 25. That is the version that's most commonly given. I will never use that version in this class. Instead, I prefer what's called the descriptive version, which is 1 leg squared plus the other leg squared equals the hypotenuse. squared. That is the preferred version in this class. Do a couple reviews here, but before we deal with radicals, let's review this. When you have an exponent, you need to expand. Point upwards, exponent, expand. Give you two examples. Root 11 squared should look like this. Root 11 times root 11, which you have already figured out the pattern that any radical times itself is just the number on the inside. So root 11 squared is simply 11. 3 root 7 squared looks like this. So you write it out, and then we're going to do outies and innies. 3 times 3 is 9. Root 7 times root 7 is 7. And 9 times 7, if you know your nines fingers, that is, whoops, let me get this in the middle here, 63. Whenever we're working with right triangles, we're going to follow this have, need, do formula. Have, need, do formula. Let me give you an example here. Look at what you have. We have one leg, another leg. There's our hypo. We have two sides of a right triangle. We have two sides. We need a third side. What do we do in this case? Ready? Step back, get your hands ready. If you have two sides and you need a third side, Pythagorean theorem is literally a superpower. It is the basis of everything else that we learn about right triangles. That's why I have pulled back or pulled into a superpower analogy. So once again, if you have two sides and you need a third side, Pythag, just like Wonder Twin powers, activate. So we are going to write out the Pythagorean theorem. Leg squared, leg squared, hypo squared. Always write out your equations. Also, always label what you're working with. This is a leg. This is a leg. Across from the right angle, hypo. Now, you write the equation, you label, and then you circle, plug, chug. Please do not drop these steps. Do not get lazy. Leg, leg, we're going to plug it right in. And don't forget your square. Plus, circle the word leg, circle leg. This is X. Again, don't drop the square. Circle, circle, 2 root 3 parentheses squared. Equation, label, circle, plug, chug. Equation, label, circle, plug, chug. Now, exponent, expand. This should read root 10 times root 10 plus x squared, 2 root 3 times 2 root 3. Root 10 times root 10 is just 10. X squared. Outies, innies, 2 times 2 is 4. Root 3 times root 3 is 3. So 4 times 3, this should read 12. minus 10. Opposite of squaring is square rooting. So our x here, our unknown leg, is simply root 2. If you can simplify, do so, but you can't simplify root 2. There's no dates there, so you are done. That is a recap from our previous lesson. Before we move on, let's review our shortcuts here. 5 root 2 times what is 10? I know I need another root 2 here, because root 2 times 2 is 2. 5 times 2 is 10. Root 3 times what is 9? I know I need a root 3 here because root 3 times root 3 is 3. And then I need a 3 as well because 3 times 3 is 9. So my complete answer here is 3 root 3. Root 2 times what is 1? It's a little trickier. So I start with what I absolutely know must be in there. I know there has to be a root 2 because the root 2 gets rid of the radical. Root 2 times root 2 is 2. And then I ask myself, what can I do to the 2 to get it down to 1? And this is all multiplication or division. And the answer is I can divide 2 by 2. So root 2 times root 2 over 2 is 1. 4 root 3 squared, exponent expand, that's 4 root 3 times 4 root 3. Four times 4 is 16, root 3 times root 3, and 16 times 3 is 48. Ready? Please take the time to do this yourself. Do not just copy. You're going to get out your red pen, pause the video, and do this in about 30 seconds. Go. Okay, welcome back. Students, did you actually pause the video and do your own work? I hope you're doing that. Get out your red pen. I want to see corrections here. If you're correct, I expect star smiley. If you're not correct, I expect a little note what you want to remember. I'm not going to explain it, just going to give you the answers. All right, we're going to use the Pythagorean theorem when you have two sides and you need a third side. Have two sides, need third side, Pythag. So let's take a look at what we have here. We have one leg, our other leg is x, and our hypo is 4 root 2. We have two sides, and we need a third side. So we are going to write our equation, which is leg squared plus leg squared equals hypo squared. Circle, plug, chug. Circle, circle, x squared. Four squared. 4 root 2, parentheses around that whole thing squared. All righty, so this is going to be x squared plus 4 times 4 is 16. Light dance. Four root 2 times 4 root 2. We're going to do this in the margin. 4 root 2 times 4 root 2. 4 times 4 is 16. Root 2 times root 2 is 2. 16 times 2 is going to be 32. Minus 16 both sides. We have x squared equals 16 square root. And our unknown leg here is going to just be 4. Look what's going on here. One leg is 4. The other leg is 4. And then that's 4 root 2. Now, you can use Pythagorean theorem for any right triangle. If you have two sides, need a third side, you can Pythag. But today, I'm going to teach you some shortcuts. Everyone likes a shortcut. But these shortcuts are only for what's called special right triangles. And when you have special right triangles, special meaning a particular situation, you only need one side. And then you can find the two other sides using this special right triangle pattern. There's a pattern there, a shortcut. The two special right triangles and the two patterns we're going to learn are for 45, 45, 90, 30, 60, 90. 45, 45, 90. Remember that. I'll complete the rest of that in a minute. And then you have 30, 60, 90. These are special right triangles and they have special shortcuts. We're going to figure that out right now. So notice these are going to be 45, 45, 90 triangles. Just a couple observations. If you have a right angle there, 45 means these two angles are equal. Right angle, these two angles are equal. Let's see what we have here. We're going to do Pythagorean theorem first. Leg squared, so 4 squared, plus leg squared, 4 squared, equals hypo squared, x squared. Leg squared plus leg squared equals hypo squared. Let's solve that one on the left. Opposite of squaring is square rooting, so we're going to square root. And when you factor 32, 2 and 16, you look how many dates you have. You have 2 sets of 2s. So 2 times 2 comes out, and that's going to be 4. 1 set of 2 on the inside, or 1, 2. And so your final answer here for your hypotenuse is 4 root 2. Look carefully what we got going on here. We have a 4, and 4 root 2. 4 and 4 and 4 root 2. On the right-hand side, let's see what we got here. We have one leg is 5 root 2. Other leg is unknown. And our hypo is 10. Leg squared plus leg squared equals hypo squared. Let's do the math together. Oops, I forgot the square here. So this is 5 root 2 times 5 root 2, x squared equals 100. 5 times 5 is 25. Root 2 times root 2 is 2. So this is going to be 25 times 2, which is 50. Plus x squared equals 100. Minus 50 both sides. X squared equals 50. Square root. Factor. And we noticed here we have a pair of 5s and a single root 2. So take a look at what we have here. There is a pattern I'm going to ask you to take a look at and try to identify. And it's the same pattern for both triangles. So let's take a look here. You have a 4 for the legs and 4 root 2 for the hypo. You have 5 root 2 and 5 root 2 for the legs and 10 for the hypo. It's the same pattern for both triangles. Taking a look here, I am not going to give you the answers for these. You're going to have to come up with it in your own. The first question is, what do you notice about both legs? What do you notice about both legs? Second is, what do you notice about the pattern going from the leg to the hypo? And this pattern is only good for 45, 45, 90 triangles. The leg is 4, the hypo is 4 root 2. The leg is 5 root 2, and the hypo is 10. There's a pattern there. I'd like you to write down your observation. Pause the video and write down your observation. Welcome back. Hopefully you put your own thought into this, because if you bring your own thought into this, even if you're incorrect, study shows by putting forth effort, you actually learn more than just copying from this video. The pattern, hopefully that you noticed, the first was an easy pattern, and the pattern is this. Since we have 2 equal angles, we have 2 equal sides. And the sides that are equal are the legs. So the legs are equal to each other in a 45, 45, 90 triangle. Again, this shortcut is only for 45, 45, 90. So the legs are equal. The hypo is whatever the leg is times the square root of 2. The other side, we went 4 to 4 root 2. And we went from 5 root 2 to 10. What happened, what was the function box in between both of these, was simply times by root 2. So the hypo is going to be whatever the leg is times root 2. So I'm going to write leg times root 2. Again, this shortcut is only for a special right triangle, which is the 45, 45, 90. Get ready to chant. 45, 45, 90. 45, 45, 90. Leg, 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 root 2. Again, 45, 45, 90. Leg, 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 root 2. Come on. 45, 45, 90. Leg, 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 root 2. One more time. 45, 45, 90. Leg, 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 root 2. Let's use this shortcut to make it so much easier. Now, I'm going to chant and touch at the same time. You should get in the habit of doing that as well. So watch where the pen goes and listen to the sounds. 45, 45, 90. Leg, 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 root 2. So notice what I did. I traced the angles. They're equal because it's 45, 45. I went over the right angle. Then the legs are equal. I mark them equal. Make sure you're marking the legs equal. Then draw an arrow from the leg to the hypo. Our function box is times root 2. So once you have the pattern, oh, it's so easy. Watch. One leg is 3. Ha! Guess what the other leg is? 3. Because it's leg, leg. Legs are equal. To get to the hypo, you simply times by root 2. So 3 times root 2 is 3 root 2, folks. Remember, because innies and outies do not talk to each other. 45, 45, 90. Leg, 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 root 2. I'll do this page with you, this page on your own. Ready? Watch how I chant and mark at the same time. You should get in the habit of doing this as well. Ready? 45, 45, 90. Leg, 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 root 2. There's the pattern. The legs are equal. The hypo is whatever the leg is times root 2. But wait, there's no leg. So it reads like this. Some sort of leg times root 2 will give us 8 root 2, which is our hypotenuse. So something times root 2 is 8 root 2. Something times root 2 is 8 root 2. Or something's 8. What times root 2 is 8 root 2? The something is 8. So A would be 8, and since the legs are equal, B would be 8. Let's try another one. Again, chant and trace at the same time. 45, 45, 90. Leg, 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 root 2. So once again, it reads from the leg to the hypo times by root 2. It reads like this. Something times root 2 is 10. Now you can see why we did all that shortcut for radicals. Something times root 2 is 10. You know you need another root 2 there to get rid of the radical. So root 2 times root 2 is 2. What times 2 is 10? The complete answer here is 5 root 2 is the complete answer. 5 root 2. It is super duper duper important you try this on your own. It's okay to be wrong. I'd rather you try and be wrong than passively copy. So get out your pencil and do your own work. Pause. Welcome back. Now you should have a red pen. Get ready to correct your work. I'll simply give you the answers and you could figure out if you got it right, star smiley. If you didn't get it right, figure out why. Ready? 45, 45, 90, leg, 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 root 2. So if one leg is 4 root 2, the other leg is also y 4 root 2. And then you have 4 root 2 times root 2. This is going to give you 8. Coming down here, 45, 45, 90, leg, leg, these are equal, leg, root 2. So you should have something times root 2 is 6. What is that something? That something is 3 root 2. 3 root 2, and if that's 3 root 2, so is that. This is only good for 45, 45, 90 triangles. Now we're going to do 30, 60, 90. 30, 60, 90. So we'll use Pythagorean theorem first. we have one leg of 5, so I'm going to go 5 squared. Another leg that's going to be underneath that sign is 5 root 3. So that's 5 root 3 squared equals our hypotenuse squared. So plus equal. Do the math on the left. This is 5 times 5. In the margin, 5 root 3 times 5 root 3. 5 times 5 is 25. Root 3 times root 3 is 3. So 5 root 3 squared is 75 equals x squared. Square root of 100, of course, is 10. On the right-hand side, let's do another. Again, a 30, 60, 90 triangle. This is called a special right triangle as well. So let's see what we have here. We have one leg of 6. Another leg, which is unknown. And our hypo is 4 root 3 squared. Okay, we're going to do the math here. 6 times 6. X squared. In the margin, we're going to do 4 root 3 times 4 root 3. 4 times 4 is 16. Root 3 times root 3 is 3. 16 times 3, it's going to be 48. All right, we're going to minus 36 both sides. That's 2, that's 1. So we're going to do square root of 12 factor to 6 to 3. And a pair of 2's comes out. And we have 2 root 3 as our unknown here, 2 root 3. Okay, there are 2 patterns going on here. 2 patterns going on here. Across from the 30 is what we call the short leg. I'm going to label it SL. Across from the 30 is the short leg. Then you have the long leg across from the 60. I'm going to use LL for long leg. And of course, here is your hypo. There is a pattern for both of these. Couple of patterns. Okay, change this. This should read 30, 60, 90. It's a typo. I'm going to be looking for that being changed. What do you notice about the short leg to the hypo? Let me just kind of highlight that from the short leg to the hypo. This is 5. This is 10. 2 root 3, 4 root 3. 5 to 10, 2 root 3, 4 root 3. There is a pattern there. What is that pattern? 5 to 10, 2 root 3 to 4 root 3. What is that pattern going this way? Then the pattern I ask you is there's a pattern from the short leg to the long leg. If you look carefully, from the short leg to the long leg. On the left, it's 5, and then that's 5 root 3, 2 root 3, 6. It's the same pattern, 5 to 5 root 3, 2 root 3 to 6. I'd like you to write what pattern you notice. I'd rather you guess and be wrong here. I'm going to be quiet, pause the video, write your best guess, and then move on. Pause. Welcome back. Let's see if your guesses were correct. This is for a 30, 60, 90 triangle. In a 30, 60, 90 triangle, you always start, always in a 30, 60, 90 triangle. You always start the short leg. I'm going to call that SL. Short leg to the long leg, that's across, is times by √3. That was the pattern. Short leg to long leg times by √3. Short leg to hypo is times by 2. I call these the sprouts. Everything starts with the short leg. So imagine your head is the stump of a tree. Say, go like this, say short leg. Okay, short leg to the long leg, you times by √3 in a 30, 60, 90 triangle. Short leg to the hypo, you times by 2. So it's like sprouts coming from a trunk. The trunk is the short leg. Let's fill it out the table over here. Short leg across from the 30. Short leg to the long leg, you times by √3. So the long leg is whatever the short leg is times √3, always, in a 30, 60, 90 triangle. The hypo is you times by 2 in a 30, 60, 90 triangle. The shortcut is only for a 30, 60, 90 triangle. Get your hands ready. And 30, 60, 90, short leg √3, short leg times 2. 30, 60, 90, short leg √3, short leg times 2. 30, 60, 90, short leg √3, short leg times 2. 60, 90, short leg √3, short leg times 2. Get out of your seat, go in the kitchen, and chant both the chants to your parents. Pause the video. All righty, guys. Let's do a couple examples together. All right, you always start with the short leg in a 30, 60, 90. So to identify the short leg, you find the 30, which in this case is right here, and you go opposite of the 30. There is your short leg. Again, the 30 is here. That makes this your short leg. Now you do your sprouts. Short leg to the long leg, like a sprout from the trunk, short leg to the long leg. Long leg is across from the 60 times √3. Short leg to the long leg times √3. The long leg is opposite of the 60 degrees. And then the other way, short leg to the hypo. Hypo is opposite the right angle, times by 2. Times by 2. It's across from the right angle. Across from the right angle. Okay, ready? So crazy easy. Once you know this pattern on the left-hand side, our short leg is given as 3. Therefore, in a 30, 60, 90 triangle, long leg would be 3 √3. Oh, crazy easy. And then 3 times 2 is 6. On the right-hand side, life is a little bit more interesting. It reads like this. Some mysterious number times √3 is 6 √3. So some sort of number times root 3 is 6 root 3. Well, guess what that mysterious number is? 6. 6 times root 3 is 6 root 3. Times by 2, my friends, and you get a whopping 12. $30, $60, $90. Short leg. Short leg to the long leg, root 3. Short leg to the hypo, times by 2. Oh, we start with the short leg. So it reads like this. Something times root 3 is 6. Something times root 3 is 6. Well, you know you need a root 3 there, because that gets you 3. What times 3 is 6? Well, 2. So this y here is going to be 2 root 3. 2 root 3 times 2, only the outies talk to each other, so x is 4 root 3. Look how easy this is. Again, it's only 30, 60, 90. 30, 60, 90. Short leg. Short leg, root 3, short leg times 2. So this one at the bottom reads like this. Something, we don't know the something, times root 3. Whoops, let me keep my colors straight here. Root 3 is 3. Something times root 3 is 3. Well, the answer is root 3, because root 3 times root 3 is 3. Ta-da! So y is just a root 3 times by 2. Outies and innies don't talk to each other, so it's 2 root 3. Ta-da! This page, try it completely on your own. Get out your pencil, do your own work, pause the video. Welcome back, red pen friends. Get ready to correct. I'm not going to explain. I'm just going to give you the answers here. All righty. So right here, this y is 6 root 3 and x is 12. Down here, the v is going to be just 4 and the u is 8. Down here, the b is going to be 3 root 3 and the a is going to be 6 root 3. It's your job, if you got any of those incorrect, to go back in your notes and figure out why and write yourself a note. If you got any of those wrong, write yourself a note. Summarize this video in your own words.